Good evening, Tel Aviv. Good evening, BlueHat. Such a great experience to see a lot of people here. After all this COVID and, live events, no more Zoom, yeah. So today we're going to talk about Web3 security. The blockchain is your SIEM. My name is Tal Barry, and I'm co-founder and CTO for Zengo, developing a secure mobile cryptocurrency wallet.
Hi, I'm Shalev, and I'm a cryptography and blockchain researcher at Zengo. Yeah.
Yeah. So what are we going to talk about today? So we'll start what the hell is Web3. Everybody's saying it. Nobody knows what it is. So hopefully after this talk, you will know. And Web3 is web on blockchain. Don't worry. We'll talk about both of these things. And then we will dissect Web3 into its three main components: the wallet, the Web2 interface, and smart contracts. And once we had dissected it, we can analyze the security of all of these three elements. And we will leverage the fact that the blockchain is your SIEM. SIEM, if you don't know this term, is Security Incident and Event Management, which is a fancy word for a database where everything is saved, hopefully. And we will leverage the fact that the blockchain is actually a great SIEM. And using that, we will present two analyses that we made, two post-mortem on recent attacks, the Badger DAO attack and the multi-chain attack, each representing a different attack vector in this triangle of Web3. And we will conclude with some aspects that we think that we can leverage that fact that the blockchain is your SIEM into something greater than just having great post-mortem, but also make it actionable so we can stop attacks before they happen and not just analyze what they did. So let's start with the beginning. And we want to start with the story. So this is Vitalik Buterin, one of the co-founders of Ethereum. And when Vitalik was a kid, he used to play World of Warcraft. And he played a lot and was able to achieve some great asset. I don't know what it is. It's a life spell. If someone played World of Warcraft, maybe they know what it is. But then the platform decided they no longer support this asset for some reason. Maybe it was too powerful or something like that. So they just took it from Vitalik, the kid. And Vitalik cried that night and realized that centralized systems are evil. And because you don't own the digital assets on that platform, the platform owns it, not you. And he decided, and we'll see it afterwards, how to break from the grasp of that centralized system. So this is your normal Web2 application, and you can see what is very easy for them, for the platform to deprive you from your assets, because everything there, the database, the compute, the interface, is all under the control of the vendor, of the platform. And the user just have a browser, but so when they want to remove an asset, they just remove it from the database or from the compute or just block it in the interface, and there's nothing you can do. You don't really own your digital assets on current web. And that's exactly what Web3 comes to change. This is the core problem Web3 is solving. So it represents the third revolution or evolution of web. If we had the Web 1, the original web, I'm old enough to remember it when it was just static and you could just read these digital brochures over the internet. Then there's the web as we know it today. It's reactive. You can read and write. You can interact with the web application. It's not just static website. But Web3 is about owning the content, owning digital assets. So how would you own that? You have to remove the control of the platform and move it to somewhere else. Where is this other place? The blockchain. So what is a blockchain? Blockchain is just a distributed database. It's no magic. I'm saying just with quotes because it's a hard problem to reach consensus in a distributed system, but blockchain solves that. And on blockchain, messages are authenticated, which means users has addresses that correspond to their public key, and they hold a private key. They have that pair, and the private key is typically saved in a wallet. And this construction is very helpful in the arena of money transfer, and that's exactly what Bitcoin did. So Bitcoin has one built-in program. We'll talk more about that in the next slide, which is basically, if we think of it as a program, it's send from source to destination an amount. So it's really a program. So when you send a transaction, this distributed database first verifies the authenticity of the message by verifying the signature. Then they're doing a very simple, executing a very simple program. You can write it. It's the second program you would write right after hello world. It's verifying that the sender has enough balance, then subtracting the amount from their balance and incrementing that into the receiver account. And finally, the result is persisted and stored on that distributed database, the blockchain. So blockchain can serve as a database. So we can remove the database from the platform's cloud and move it to the blockchain. But still, we have to handle the execution, because right now it's just a database. It's not really executing a code, and we want to play games, World of Warcraft, for example. So this is the classic blockchain. You just have a wallet. You want to send something. You send a signed transaction to the blockchain. And when someone sends a transaction to you, you get it as a notification from the blockchain. But we want to go further. And this is where we meet Vitalik again. Vitalik, the little boy from the story of World of Warcraft, now is a few years older, and he co-founded Ethereum. So Ethereum has the same built-in program, the same as Bitcoin, but it has a really great feature. And this is like what the new innovation that Ethereum brought to the blockchain world. You can also, you don't just hold in this database just balances. You can also store programs and something like DLLs, libraries. You can upload binary code, and it will be stored and have some address. And when you want to interact with it, or anyone wants to interact with it, they just need to send a transaction to that address. And that transaction is serialization. It's an RPC. The next talk, by the way, is about RPC. So the same concept. You serialize the function name and the parameters. And now, instead of the blockchain just executing that one program of transferring money, I execute your arbitrary code, the code that someone has uploaded in the past. It gets evaluated with the parameters that you specified, and the results are then persisted to the blockchain, to that distributed database. So we gained the ability to upload arbitrary code into a distributed system. So we managed to move also not only the database, but also the compute to the blockchain. So we're almost independent from the platform. So the platform no longer controls that and cannot change the rule in the middle, like World of Warcraft. So what we got, this is Web3. We married web and blockchain together. And now there is that triangle. So when you want to do something in Web3, you go to the Web2 interface, because we are engineers. We say we will figure out UX in the end, and so UX, the user experience, still stays on the old Web2 interface. But you go there, and this interface interacts with your wallet and suggests transaction to be signed. If you want to sign it, then you go ahead, and, as a user, you sign it and send it to the blockchain. And the blockchain executes that on the smart contract, and the Web2 interface is updated with the result, and this triangle goes on and on. And so there are three main components to Web3: Web2 app interface, wallet, blockchain, and blockchain smart contracts. And for example, this is the poster child of Web3, NFTs or digital assets. So what does it mean that the user owns NFT? The ownership is public on the blockchain. You can look at a blockchain explorer to visualize the blockchain, and you can see that this address is the owner of this magnificent Bored Ape. And because the user is not bound to a specific platform, it can be listed in multiple marketplaces. It can be listed on OpenSea and Rarible because the user actually owns it and can transfer it however they like. So I think we can stop the talk here because we got a perfect Hollywood happy end, like Vitalik, the little kid, deprived from their digital assets, so he takes his revenge on centralized apps and decentralize them, and in the way, he becomes a billionaire and everybody happy. So apparently there are some problems, and that's where we're going with the talk. So Web3 has a serious security problem. So Web3 apps are being hacked with hundreds of millions of dollars, but also users. This is a screenshot, someone complaining to their wallet vendor that all of their digital assets are gone and say, okay, there could be 5 reasons why it happened. It's normal, it's Web3, you can lose everything. And so let's go on and dissect that problems in the triangle model. So first, the wallet. Problems with wallet is actually a problem with the private key. The private key can be stolen, hacked, socially engineered, or just get lost. And this is not new to Web3, so we'll just briefly mention it, because this is the same problem is with classic blockchain. Bitcoin has that problem too. It's not, Ethereum did not invent that. So, and the solution is around secure storage of private keys. Could be hardware or what we're doing in Zengo, multi-party computation. So in Zengo, in our wallet, we utilizing MPC and using distributed algorithms, state-of-the-art cryptography, we are able to generate a key in a distributed manner and sign messages in distributed manner, so the private key is never in one place and cannot be stolen, easily stolen. So it's a lot harder for the attacker to steal that. But we don't want to focus on that because, again, this also existed for older systems. When we want to start looking into specifics of Web3 attack, so Shalev, go on with the first thing.
Okay, so hi. So what we're going to talk about now is we looked at the wallet and the issues that we have on that end, and now we want to look at the front end. So this is like the Web2 version. That, like we said, at the end of the day, you do have a smart contract, and you have wallets that can interact with it, but the users don't know how to actually interact with the blockchain, and they don't know how to form these special transactions and create these method calls and send them to the blockchain. They need some sort of GUI to do this, right? So we're going to look at a specific one called Badger DAO. Now, Badger DAO, their like slogan was that we are bringing DeFi to Bitcoin. They sort of want you to be able to earn interest on your Bitcoin. It's a very common thing in DeFi, and the way that they're doing this is that you have some sort of wrapped version. We're going to explain the wrapped version in a second, but they have some sort of wrapped version of Bitcoin on Ethereum, and they let you sort of deposit it into all these kinds of vaults, and then you get these sort of incredibly high annual percentages of like 75% on your Bitcoin, which is really nice if you want to do that. So firstly, we'll just mention quickly something called an ERC20 token. So you might have heard the term ERC20, you might have not. But essentially, like we said, Ethereum is just a virtual machine that can run any piece of code. So something very simple that you might want to do is implement, wait, I actually want to have a token like for myself. I know there's Bitcoin, there's Ethereum, and there's plenty of others. But I don't want to go and create this whole blockchain and this whole consensus protocol and everything just because I want to implement my own coin for maybe my company or whatever it is I'm doing. In Ethereum, the Ethereum Foundation sort of worked on this ERC20 token. It's like an RFC in normal like TCP protocols and internet protocols. It's just a standard. This is how you should implement a program that implements a token. And what does the token have? Well, you can see all these kinds of functions that you have to sort of implement, the total supply, balance off somebody, transfer, you can transfer money, you can allow somebody to spend your money, we'll talk about that in a minute, and you can do all kinds of things. Okay, so now we know there's this way of doing, creating a coin, and everybody can create a coin very quickly. It's just writing a few lines of code and uploading it to the Ethereum virtual machine. We'll sort of talk a bit about, Okay, we'll talk about how BadgerDAO was hacked. So what was hacked here, as I said, was this interface, the Web2 interface that people went to go on, like app.badgerdao.com. And what happened was, we'll sort of talk about the story here a little bit. In August of 2021, there was a vulnerability disclosed in Cloudflare, and some attackers, we won't go into the details of the vulnerability, but essentially the vulnerability worked in a way that you send a request, Cloudflare is a CDN, you can send static content to your users very efficiently. One of the features that Cloudflare has is injecting JavaScript into your static content, which is obviously very interesting. And what happened was the attackers managed to override that and inject their own JavaScript via this sort of one-click vulnerability that was discovered, and they sent a request to inject some JavaScript, and the admin sort of didn't notice properly and clicked accept, and then they could sort of inject whatever code they wanted. So now we want to look about sort of what they actually did. So luckily, like we said, blockchain is your SIEM, so you can see everything that happens on the blockchain, but you can't see everything that happens in Web 2. Luckily, we have the Web Archive, and what we can do is sort of see the version from November 2021, and you can see this bunch of code here that wasn't before. This is the malicious code. It's obfuscated. We have some GitHub project where we deobfuscated it, but let's go to what they did. So the attack worked, what the code does, essentially three main things. So the first thing, they want to sort of hook the communication of the dApp, basically the Web 2 interface, with the wallet, right? We said there's a triangle, there's the blockchain, and there's the Web 2 interface, and we have the wallet. And what happens in sort of the UI part is that the UI works hard to analyze the blockchain and create some sort of meaningful transaction for the user. Say the user is looking at the vaults and they want to add some more money to one of the vaults, then the GUI just sort of looks into the blockchain, knows the right smart contract, the right method to call, the right parameters to call it with, and it forms this transaction and it sends it to the wallet. So what the attackers want to do is obviously to hook this mechanism. So all they did, the way this usually happens, was specifically with a wallet called MetaMask. The attack only targeted MetaMask, but every other wallet works in a very similar way. MetaMask is just a Chrome extension, and it injects an object called Ethereum into the JavaScript namespace. So you can sort of see here, try to sort of deobfuscate it. They basically just take the Ethereum object and they hook a specific function. And this function was, the one that they're sort of looking in is one that's called ETH send transaction, which, as the name suggests, it sends a transaction to the Ethereum network. So they were hooking this, and you can see they were sort of looking for specific methods. There's some sort of claim and withdraw. And these are just the normal things that you do when you interact with your vaults on BadgerDAO. OK, so that's the first thing. Now they're able to hook the communication between the wallet and the Web 2 interface. Now what do they want to do? First of all, we want to filter unwanted victims, right? Because you don't want everybody in the world to see, you don't want to sort of try and attack everybody, because then you might attack 1,000 people with like $1, and then you won't really get anything out of the attack before you get blocked. So first of all, what they did, they sort of had this blacklist of BadgerDAO devs, which they didn't attack. And the other thing that they did is they would only attack somebody if they have more than $50,000 in the total balance on BadgerDAO. Another cool thing that we found is that they have this special test account that's sort of it's their own address. So when you send an exploit into the wild, you want to check it out in the real world to make sure it works. So this is how they did this, so without sacrificing 50,000 of their own money. And sort of the last thing is, OK, so we injected the script. We can filter whoever we don't want. But now we actually want to do something, right? Like how do we fool the user into signing a transaction that will give me money? So we talked a little bit about ERC20, and we talked about sort of allowing somebody else to spend your money. And we'll go into that in a second. But the way that you do this is with something called an approve function. And the way this works is essentially you're approving somebody, basically an allowance to spend your money on your behalf. It sounds a bit strange, but it's usually used for decentralized exchanges and all kinds of things, and it's based on the sort of limitations of Ethereum. So here you can see that what they do is if what you're trying to interact with is the vault with most of the money, they will send you a normal approve that sort of let the attacker spend your money. But then if you're using another vault that's not the vault with most of the money in your account, then they will sort of do this sort of sneaky increase allowance, which, as we'll show in a second, looks a bit different. So like on the left, you have the normal sort of allowance. MetaMask asks you, do you want to give whoever it is access to your Shiba Inu tokens? And then on the right, the exact same thing would happen, but so MetaMask just sort of, it will write increased allowance, but most users might fall for that more easily than the sort of very plain and simple, somebody's trying to access your funds. We created this test, we injected it into sort of a live session via Burp. You can see that this is the malicious script sort of works and injects what it wants us to do. This is the approve, and this is what it looks like with increased allowance. And now we'll talk very briefly about how the attack actually unfolded. As we said, blockchain is your SIEM, so you can just go in the blockchain and see exactly what happened, like how the attack unfolded, which is really cool. So we can see that there's the first approve function. On the 20th of November, there's the transaction. You can see it like on Etherscan. And there's an approve to where to, this one FCDB is the attacker address that all of the funds were sort of routed to at the end. Then you can see that a few days later, on the 1st of December, you have an increased allowance, which, as we said, is like the sneakier version. And this worked on somebody moving $50 million. So now the attacker has control of $50 million and all the other sort of money that they have gathered until now. And so everybody was sort of talking about who this $50 million fish is. And according to press, it's Celsius, which is a big company that sort of lets people have interest on their Bitcoins. And one of the ways they're doing it is obviously via via the Badger DAO system. They were using MetaMask. So this is a bit crazy. It's like $54 million you're moving in one transaction. And it's all sort of in a MetaMask wallet that everybody uses, like a consumer-grade type of solution. OK, so now that they have this big fish, they want to pull it all in. So you can see it's probably automated 6 hours later, right at 000 UTC time. You can see that the transactions are sort of in the reverse order. So the first transaction is approve infinite for this wrapped Bitcoin token. And then you see the users just interacting normally with the moving tokens around, what they were doing. And then sort of a bit later, you can see minus 900 Bitcoins taken from their account, which is it was $54 million. And then if we look sort of what happened after that, you can just see this transfer. This all just moves funds to the attacker address. So it's like everybody they could get as fast as they could. And the interesting thing was that sort of within a few hours, Badger DAO managed to sort of freeze everything. And the attackers managed to steal $120 million to their accounts. So now we'll talk about the smart contract side of things with Tal.
Thank you, Shalev. So we talked about two of the three parts of the triangle. We talked about a little bit about wallet attack. Now Shalev talked about interface attack. Now let's talk about attacking the smart contracts themselves. And again, we'll use the fact that the blockchain is our SIEM. We will analyze the multi-chain router incident. So the multi-chain router is a bridge allowing users to freely swap tokens. I hear that tomorrow there will be a talk by Niv Yechezkel about attacking bridges. So this is, you can consider it as a preview. And multi-chain was exploited mid this January, so 2 months ago. And almost 2,000 ETH was stolen, so around 5 million, 6 million, depend on the Ethereum rate today. And it's still ongoing, by the way. So we'll talk about that a little bit. And this was because of smart contract logical error or vulnerability, as we call it. And there's more extended analysis on our blog, but we will present the gist of it. So blockchain is our SIEM. We were able to locate that one of the exploiting transaction. And, well, we said transaction is just a remote procedure call, RPC. So it's just code. Let's debug it. Let's run it. Let's rerun it. Let's replay it. And there are tools, free tools to do so. For example, Tenderly. This is the screenshot. And we put that transaction in this tool, and we were able to see with which function it interacts. So it interacts with that any swap underlying with permit. So what does this function do? And again, this is Web3, so all of the code is open source, so you can audit and don't need to blindly trust that application. And let's zoom in on the first two lines of the function, because this was the attacker has exploited. So originally, what is the meaning of this function? This function, you present a permit, a signed permit from a user to it. The caller presents another user's permit, and but it's signed. So the smart contract is supposed to verify the signature, and if it's verified, then move the money from the user to the caller. So the first line is really because this bridge is moving tokens from one chain to another. It needs some internal representation, so it's AnySwap, multi-chain former names, internal token that has it's wrapping that token, the real token, so it's just a parameter within this AnySwap token. So the first line just extracts that inner token, and then it calls that inner token, the underlying token, permit function. And this permit function of the token is really supposed to verify the signature. This is denoted by the VRS parameters in the end of the line. And if it verifies it successfully, then the execution continues. And if it's not verified, then it throws something and the execution stops. So the rest of the function assumes that if we got past that, then the signature was verified correctly, successfully. And this is what the attackers really abused, because although it's intended to be used just with any swap token, nothing in the code enforced that. There should have been an allow list. This is the primal scene, an allow list of allowed any swap tokens that are supposed to be used with that, but there wasn't. And we're seeing that in the debugger, that the attacker was able to call that function directly, and token is an attacker control parameter. So they put their malicious contract, and that malicious contract returns the underlying token is WEF. Okay, so it's not working according to plans, but we don't have to worry because we have the next line that was supposed to verify that signature. So let's see. But the problem is WEF token does not have a permit function. Well, we're saying, okay, that's it's not so bad actually, because there is no permit. The virtual machine will try to execute that. They get some error, and the execution will be stopped. No, because in WEF there is a mechanism that's called fallback function. You can see it again from the debugger. And so if the virtual machine does not find the function, it falls back to another function. And in this case, deposit, it doesn't really matter. The most important thing is that you call a permit function, and it does not fail. It returns normally without really checking the signature. So although the attacker didn't have a valid signed permit, they got past that check and can spend the victim's money. Okay, so, and that's led to 6 million losses for multi-chain or router users. We were able to further analyze this attack. There's a great tool called Dune Analytics that actually ETLs just move the database, that distributed database, into a SQL-based database. And so we can query it. And we ran a query to see when was the function first used. We were sort of wondering what is the normal usage of it, how much it was used. And the answer is it was never used before the attack. Like the first user, the first time this function was used in production was by the attacker. So actually this is redundant code that had this vulnerability, but no one got to that because it was never used. So this is one interesting insight. And just taking it to the next level, Dune Analytics also has dashboarding utilities. So right now we can monitor this attack in online, you can go to this dashboard that we built, and it's updated online with more and more victims that are still being abused by this attack. So we finished with the pessimistic part of this talk, a lot of hacks. Now let's talk about how we can defend. And we're very optimistic about Web3 security because we have done dozens of post-mortems, so we gained a lot of insights. And because blockchain is our SIEM, like it's really paradise for researchers because usually you don't get to see the raw technical data of attack. Only the incident response company that comes into the victim site and touch the systems there are able to see the gory details and derive some meaningful technical insights. But in this case, everybody gets to see the data. It's just you and your creativity because you have all the data. Now come up with insights and discover that, okay, there's a usage of a sneaky method that does not look well on MetaMask, as Shalev discussed, or this function was used and it's a redundant function. So we were able to derive some meaningful insights that, you know, it was just us in our analysis. No, we didn't need any help from anyone for that. So this is great potential, and I encourage all of you to go into Web3 security because the potential is so great and you can learn so much and do a lot of things by yourself without needing to depend on third parties. But we also realized that it's not limited to post-mortems, like it's just, you know, scratching the surface of the potential, because most of our analysis, everything we did, could be done in real time and beforehand and as we go. So there is a potential here to build a firewall-like solution to protect customers and users against rogue interfaces, like the BudgetDAO case, and protect also smart contracts against rogue transactions, such as the multi-chain case. And there are some special bonuses for all of you firewall lovers in the crowd. So, because the blockchain is your SIEM, and everybody that ever created a rule for a firewall knows this process. You know, you create a rule, you think you thought about all the eventualities, and then you ship it, and 2 days later, the support is full with the false positives report, and you tweak it, and it's somewhat better, but then other things come up, and so on and so forth. So this is really a cycle of tweaking. But when the blockchain is your SIEM, you have full access to everything that ever happened. So you can test your rule, and if they are false positive, you tweak them before you deploy. So you can get with really good rules right away. And same goes for anomaly detection. So usually, like if you ever did a proof of concept in a customer side, so you can never show anomaly detection there because, oh, it needs to learn now for 3 months and so on. But no, we have the full history. We can learn from the whole of the history, everything that happened, or a portion, or the relevant portion out of it, and we can come up with a good model and also tweak it before we deploy it. So this is great potential for security solution. So let's make it more concrete. What we do? So we can do a Web3 personal firewall, again, to protect users against Web2 interface injections, just as Shalev showed with the BudgetDAO attack. So how could it help in that case? So we could have analyze rogue approved transaction based on the reputation of the spender address. So in the case of BudgetDAO, the address was EOA, a regular address, and not a smart contract. So this is a bright red flag that we could have flagged for the user, or just block it, or let he or she know. But even if the attacker was smarter than that and were using a smart contract, then this contract would have serious reputation problem because who deployed it, like was it related to Badger DAO administrator? The deployer, is the contract code publicly available? If I was an attacker, I would probably not publish my smart contract attacking code and so on and so forth. So it's really a solid defense against such attacks. And it can also be used to protect apps, smart contracts, against malicious attacks, malicious transactions, such as the multi-chain. So how we could have helped them? We could have detect the usage of redundant function, or if the function was not redundant, we were able to learn that it is always called with any swap, multi-chain, internal representation tokens, and not with this abnormal smart contract that the attacker had called that function with. So there's a lot of potential, and this is just an example in that kind of solution. So we want to conclude with that, and this is what we would like you to take home with you. So I hope that at the very least you now have better understanding what Web3 means and why it's important, the ownership upon digital assets, and why it's a revolution. But currently, Web3 security is in very bad shape. However, let's not be pessimistic, because there's a great potential to secure it, because the blockchain is your SIEM, and this is an untapped potential. Like, it's just waiting for guys like you to come up and do it, and I'm sure some of you are already planning to do that. And even if you're not doing it, just this is a really interesting field for security researchers, because the data is available to all of you, and it's paradise. It's really fun to do it. So I encourage all of you to learn more about it, do it, play with it. Everything's free, everything is available. And if you have further questions, come and talk to us right after the talk, or in all of this digital media. So thank you so much, BlueHat.
Thank you.